Introductory Statistics for Data Analytics is a 7-week course on the basic concepts of statistics. The overarching goal of the course is to teach students how to use data to learn about the world statistically. The course has 3 instructors, all from the Department of Statistics at The Ohio State University.
Hi, I'm Ellie Kazar, Professor of Statistics.
Hi there, I'm Osman Türkmen, Professor of Statistics.
Hi, I'm Vince Vu, Associate Professor of Statistics. The course is divided into 6 modules. Each module is taught by one instructor. Asu teaches Module 1, I teach Modules 2 and 3, Ellie teaches Modules 4 and 5, and the final module is taught by Asu.
In Module 1, we will learn about collecting and summarizing data. Different data sets come from different sources. We can get data as part of observational studies, such as surveys and experiments. We will learn about the advantages and disadvantages of each data collection method. We will also learn how we explore data using graphical and numerical summaries. Using different examples, we'll learn how we can use different summaries to understand the features of the dataset. Throughout this entire course, we will be using the R and RStudio software packages. And in Module 1, we are going to start learning how to use these software packages.
Modules 2 and 3 deal with probability and sampling distributions. We often use the word chance in day-to-day life. For instance, any discussion of the possibility of rain tomorrow would inevitably involve the word chance. Probability theory is a mathematical framework that gives a precise meaning to the word chance. It allows us to think precisely about the things that could possibly happen and to assign probabilities to those occurrences. Statistics uses probabilistic models to think about how data might be generated, and so that we have a path to learn about the world from the data while incorporating our natural uncertainty about it. Modules 2 and 3 together will introduce you to the basic concepts and rules of probability.
When we try to learn from data, we often attempt to answer 2 kinds of questions. For example, consider a study of patients treated for a liver disease. We might want to know if their liver health can recover at all from the damage caused by the disease. Alternatively, we might want to estimate how much the patient's liver health recovers after their treatment. The first kind of question relates to testing, whereas we would use estimation to answer the second. In Modules 4 and 5, you will learn how to formulate such questions, how data can be used to answer them, and also how to implement these data analysis techniques in the R software. I'll be demonstrating these points, and students will practice them using a number of different examples that are intended to appeal to a broad audience.
In Module 6, we will learn how to explore relationships between variables. We will introduce the idea of association, which allows us to measure possible linear relationships between variables and use linear regression models to predict one variable in terms of a linear function of another. Throughout the module, we will use data collected by the physicist James David Forbes, who wanted to understand the relationship between the boiling point of water and atmospheric pressure. We will use measures of association to see how strong the linear relationship between these variables is, and we will use a regression model to predict atmospheric pressure, in fact the log of the atmospheric pressure, from the boiling point while accounting for the uncertainty in measuring these variables. Understanding linear regression models forms the basis for learning about more advanced data modeling techniques that you will learn about in other courses in the sequence.
And that is Introductory Statistics for Data Analytics in a nutshell. We hope that this video was informative and hope to see you online soon.